कैसे हैं आप? तो बच्चों आज हम इंटीग्रेशन की लास्ट एक्सरसाइज करने जा रहे हैं। लास्ट टॉपिक इंटीग्रेशन बाय पार्ट्स। तो इंटीग्रेशन बाय पार्ट्स का यूज कहां होता है? ऐसे इंटीग्रेशन के क्वेश्चंस विच आर द प्रोडक्ट ऑफ टू फंक्शंस, फॉर एग्जांपल x into sin x, x into log x, x square sin inverse x। इस टाइप के फंक्शन जो है विच आर द प्रोडक्ट ऑफ द टू फंक्शंस आर इंटीग्रेटेबल बाय द फार्मूला ऑफ इंटीग्रेशन बाय पार्ट्स। तो फर्स्ट ऑफ ऑल, व्हाट इज द फार्मूला ऑफ इंटीग्रेशन बाय पार्ट्स and what is the procedure to select the first function and the second function? So formula for the integration by parts is integration of fx into gx into dx. This is first and this is second. First function as it is, integration of second minus integration of derivative of first into integration of second and whole integration. So in the formula we have to apply two types of brackets, small brackets as well as close bracket. This dx is represent the integration of whole functions, derivative of fx and integration of second. इसका दोबारा फिर इंटीग्रेशन करना है होल का. दिस इज द फार्मूला ऑफ इंटीग्रेशन बाय पार्ट्स. तो बच्चों हमने ये फर्स्ट फंक्शन और सेकंड फंक्शन ये चूज करने में भी नियम है. नियम इसलिए बनाए गए हैं क्योंकि हम देख रहे हैं कि सेकंड फंक्शन का ज्यादा से ज्यादा इंटीग्रेशन हो रहा है. यहाँ पे भी gx का इंटीग्रेशन हुआ और यहाँ पर भी फर्स्ट पार्ट में भी फार्मूले के gx का ही इंटीग्रेशन हुआ. इसका मतलब ये है कि सेकंड फंक्शन वी हैव टू चूज इन सच ए वे दैट विच इज इजिली टू इंटीग्रेट. So in the questions of integration by parts, we have to choose the first function by this rule, I late. And what is this I late? What is the meaning of this? Meaning of this is that if there is inverse trigonometrical functions between these two functions fx or gx, then first preference will be given to inverse trigonometrical functions. And if inverse trigonometrical function is not there, what logarithmic function is present in these two, then logarithmic functions will be taken as the first function. And if inverse and logarithmic are not there, what algebraic is there, trigonometric are there, exponential are there, then you have to take the algebraic functions such as x square, x to the power 1 by 2, x to the power 3 by 2. These are algebraic functions. First preference will be given to them after inverse and logarithmic. And if trigonometrical function is present in the questions and algebraic, logarithmic and inverse trigonometrical functions are not there, then trigonometrical functions should be given as the first preference. And at last exponential functions should be given first preference if other functions are not present in that product of two functions. Inverse, exponential and trigonometricals can be replaced each other. Either you can take exponential as the first or you can take trigonometrical function as the first. In the similar manner, algebraic and trigonometrical functions, algebraic should be given the first preference. So this is the method. Now let us discuss this rule and this formula with the help of applications. Now the applications point of view. Find the, now this is the question number 1 of the exercise integration by parts. Integrate x into sin x into dx. Because it is the product of the two functions, hence we have to apply the formula of integration by parts. And in isolate, algebraic should be taken as the first and trigonometric should be taken as the second. Algebraic is x, this is first, and trigonometrical function should be taken as the second. Hence it becomes, by applying the formula is integration of fx into dx into dx is equal to, this is first, this is second. First function as it is integration of gx into dx minus integration of derivative of first into integration of gx into dx whole dx. This is the formula, and after applying this formula we get I is equal to first function as it is, x as it is, integration of sin x into dx minus integration of derivative of first integration of sin x into dx whole dx. Now this becomes integration of sin x is minus cos x minus integration derivative of x is 1 and integration of sin x is minus cos x into dx. This again becomes minus x into cos x minus minus plus integration of cos x into dx. Now integration of cos x is, at last, integration of cos x is plus sin x minus x into cos x and plus sin x and plus c. That is the answer of this question by integration by parts, and this is the method and this is the procedure to tackle to solve the questions of integration by parts. Write the formula, adopt the rule of isolate, and then apply the formula and solve the question. You get the answer of this question. That's all. Now question number 4. Integrate x into log x into dx. This question is also in the product of the two functions, x and log x. And by the rule isolate, logarithmic function should be given the first preference before the algebraic. Hence, here is logarithmic and it is algebraic. you have to write log x as the first and x as the second. This is first and this is second. Why this rule? We have to take log x as the first function. Now the formula of integration by parts. Integration of fx into dx. This is first and this is second. First function as it is integration of second minus integration of derivative of first into integration of second and whole integration. This is the formula. This is very, very important to write the formula before applying it. Now, applying the formula, we get log of x as it is integration of x into dx minus integration of derivative of log x integration of x into dx and whole integration. We get log of x into integration of x is x square upon 2 minus integration of derivative of log x is 1 by x and integration of x is x square upon 2 into dx. Now taking 1 by 2 outside and cutting x with x square, we get x square upon 2 into log of x minus 1 by 2 into integration of x raised to power 1 into dx. Now integration of x raised to power 1 is x to power 1 plus 1 upon 1 plus 1, that is x square upon 2. It becomes x square upon 2 into log of x minus x square upon 4 plus c, because integration of x is x square upon 2 and x square upon 2 into 2 becomes x square upon 4. This is the method and this is the procedure to solve such type of questions of integration by parts. That's all. Now question number 8. Integrate x into tangent inverse x into dx. It is also the product of the two functions. One is algebraic and second is inverse trigonometric functions. Therefore, we can solve these questions by integration by parts. And by the rule of I8, we have to take inverse trigonometrical function as the first and algebraic as the second function. Therefore, it becomes tangent inverse x into x dx. Tangent inverse x as the first and x as the second function. And formula of integration by parts. Integration of fx into gx into dx. First function, second function. First function as it is. Integration of gx dx minus integration of whole derivative of fx into integration of second dx and whole dx. Applying the formula, now it becomes tangent inverse x as it is integration of x into dx minus integration of derivative of tangent inverse x and integration of x into dx and whole integration. It becomes integration and dx. Now integration of x is x square upon 2 and derivative of tangent inverse x is 1 upon 1 plus x square. Hence writing these two, we get tangent inverse x into x square upon 2 minus integration of 1 upon 1 plus x square into x square upon 2 into dx. Now taking 1 by 2 outside, the sign of integration, we get x square into tan inverse x upon 2 minus 1 by 2 integration of 1 plus x square upon minus 1 x square upon 1 plus x square into dx. Now, in order to find the integration of x square upon 1 plus x square, it is clear that the degree of the numerator is equal to that of the denominator. If the degree of the numerator is equal to or greater than that of the denominator, then you have to divide numerator by denominator till the degree becomes the less than that of the denominator. So before taking the integration of this, we have to divide x square by x square plus 1, that is denominator, by 1 x square plus 1, subtracting we get minus 1. Hence, this can be written as 1 minus 1 upon 1 plus x square. Now, after dividing numerator by denominator, we get 1 minus 1 upon 1 plus x square. Because minus 1 was remainder and 1 was quotient. Therefore, it becomes x square into tan inverse x upon 2 minus 1 by 2 into integration of 1 dx and minus minus plus 1 upon 1 plus x square into dx. Hence, at last, the answer of this question becomes x square into tan inverse x upon 2 minus 1 by 2 into integration of 1 into dx is x, because derivative of x is 1. And integration of 1 upon 1 plus x square is tangent inverse x plus tangent inverse x plus c, and this is the answer of this question. We can take tangent inverse common from first and last and write the answer in such a way: x square upon 2 plus 1 into tangent inverse x minus x upon 2 and plus c, and this is the solution of this question by integration by parts. We have to take precautions while choosing the first function or second function. We have to adopt the rule of Eilert. And this is the answer of this question, that is x square plus 2 upon 2 tangent inverse x minus x upon 2 plus c. That's all.